The whole cold chain has to be on the natural side. It doesn't make sense to have a banana or whatever, which is produced biologically, and then it's transported with a lot of F-gas emission. This will not happen in the future anymore. So this has to be also taken into consideration. There will be something coming up in the near future. I'm very sure.
Welcome to our final session of day one of the ATMO Asia 2020. This is our suppliers panel focusing on the cold chain applications. And we are very glad to have two presenters, starting with Andreas from TECO, the Managing Director of TECO. And he is going to be covering a very interesting topic that is very relevant to the local industry in Southeast Asia and Philippines. So he's joining us from TECO studio in Germany. Andreas, welcome.
Can you hear me
Andreas, now? Absolutely. Please fire on. The stage is yours.
Perfect. Sorry. Yes. So welcome from my side, from Germany. I hope you're all well. Unfortunately, some crazy times. We want to meet each other personally, but it's not possible at that time. So greetings from Germany, and let's go on. So my presentation today is about the easy startup of CO2 racks, what has to be considered. So this time I don't want to speak about energy efficiency from CO2. I don't want to speak about technology. I think you all heard that already. So we know that there's different natural refrigerants in the market which show its efficiency. So this is not a problem at all. But we see in the field, there's a lot of questions, and we did some startups the last 2 years in some countries which were completely unexperienced with CO2. We had startups in Colombia, in Chile, and even Devin, your last map was not correct. We have now also CO2 running in Israel, which is a hot climate in logistics center. And also this startup, I want to show you some information and what has to be considered on that side. So it's a little bit a light presentation, but I think it will be fun. So CO2 can be used in all different kinds of the cold chain, you know. We talk about logistics center, hypermarkets, supermarkets, small markets, discount stores, convenience, and even plug-in cabinets. You can use R290 as natural refrigerant, but you can also use CO2 nowadays. So it's getting really a commodity. As far as we are talking about Europe, natural refrigerant is state of the art, and nobody else is doing anything else anymore. So just a message from my side. But what we are talking today is logistics centers, and CO2 is also perfect for that one. What we see nowadays coming to our portfolio, what we are offering, you see there is a very small range. We talk about up to 5 kilowatt. This is a small condensing unit, like a plug-in or water loop, you can use it. Going up to the big ones, which we are talking about for one rack, 600, 700 kilowatts on one side as a standard. Even if you don't do standard, if you go individual, you even can have it more bigger. Not only from us, also from other suppliers around the world, it's getting really commodity. So we see in Europe nowadays, we are doing really cold storage logistics up centers up to 4.2 megawatt empty and LT with CO2. So it's getting high market share, but also small logistics centers, which we are seeing in other countries, depending on the logistic chain. We talk about 100, 200 kilowatts. This is nowadays moving towards CO2 in Europe. And not only in Europe, we have now installations, as I said, in Israel logistics center with CO2, and also in South America. South America is picking up very fast. And as you probably, some of you might know, I'm a little bit, have a connection to Asia. My wife is Thai. So I worked a long time with people in Asia. And for me, it's a little bit, how should I say, I'm feeling a little bit sad that Asia is not moving as fast as, for example, South America, because the refrigeration guys in Asia have a very high knowledge. And I think it's the matter of time that they should pick it up. So what has to be considered? Of course, you have to have a right relationship. We as manufacturer, we manufacture a rack, we have components and so on. But most important is the contractor, which needs to be trained, of course, to make a setup on CO2, but also the operator need to know what he's doing. And if all goes together, you find the right relation and you find market. You see in some markets, the end user is pushing for natural refrigerants. In some markets, the contractors is pushing because they see the advantage for the future. And also manufacturers has to be ready to supply. And if we talk about food chain generally, I think it is always come together. The operator have to trust the contractor, and the contractor has to trust the manufacturer. Otherwise, you cannot do any business if there is no trust in technology, in relation, and in the total market. Starting with CO2, here's a picture of two guys who made their first startup on a CO2. A lot of people say, hey, you have high pressures. Yes, of course, but the high pressures is not a problem to handle. You have different circuits than a normal standard one. I explain to you later. You have different pipe dimensions, which is sometimes which people start with CO2 a little bit strange, that they understand you have to have maybe completely different pipe diameters. You need to have the right spare parts in a country where there's no spare part logistics for CO2. So if you want to do something like that, you have to have also to take care that you have the right spare parts on a stock at side, if there is a case, to be able to repair something. And of course, it sounds a little bit strange, but availability of refrigerant and oil. So for example, we had a startup, the slide will come later, in Colombia, where we had, it was not in Bogota, it was somewhere, I think, 1 day drive from Bogota, a cold storage, a big one, and there was not enough CO2 in a big bottle. So they were bringing small bottles for a big charge of 700 kilogram, small 30 kilogram bottles outside. And then there were even not enough bottles in the market. So the bottles have to go back to the supplier, be refilled. And these things like that have to be considered if you want to start it and if you want to start the business. Nowadays, even Colombia is getting more and more commodity because we see more and more CO2 in the market, supermarkets. So this is not anymore a problem, but the beginning was always a problem. High pressures needs new testing procedures, not only for us as manufacturer. So we are doing different tests now, but also on site. Because it means you have to take care that you have a higher tightness pressure tests, of course, and you have different pressure levels inside of a system. But to be honest, for a technician, it's not so difficult to handle that one. You see the different circuits, you have a high pressure level, you have a medium pressure level, and you have a low pressure level. And this is also low temperature, medium temperature, and you can call it high temperature, but high pressure level going up like a normal system is a condenser. In this case, CO2, it's a gas cooler where you have to take care, and you have to make your pressures testing according to which area you are to have a tight system. So system has to be tested, of course, and just to give you a hint, what has to be done. So you see low temperature in this area, pressure testing, and there are always valves which you have to close. So for example, when we had the first stop in Israel, we give that guy some PNID and showed them, hey, you have to close this valve, you have to shut up down here to be really sure that you can make the right pressure testing for these components, because these components are suitable for this kind of bars. The next one, close here, make your pressure testing here for higher pressures, and so on and so on. And you see also some pressure tests which are going in. So that is what we are talking about. Medium pressure, and here's the high pressure stage. So you have to give the contractor the knowledge to do that. So that means from our side, of course, the first effort to have one plant in a new country, which is not used to it, you have to give the customer much more information. But what we see nowadays, the example from Israel is, I think, a very good one, because these guys have no clue about CO2. They come to us, they had a 2 days training, and the rest was online, because then COVID starts and we cannot go there for startup. They cannot come anymore for training. So basically it was a share of information by online, and they made their startup by themselves, which worked very well, because nowadays, like we do now, we can have some MS Teams or Zoom calls, whatever. And so they had a startup without any issue, which is really great. So higher pressure level up to 130 bar. So now people nowadays say, hey, high pressure, oh God, what to do? Basically, it is not a problem, because the components which you have to buy for such systems are ready for these high pressures. So that doesn't mean it will explode or whatever. You have your safety valves. The safety valves, if you reach a certain pressure level which is above, will just blow off. So it is not a big problem on that one. So don't worry about the high pressures. This is not a problem. We don't face any problem in Europe and also South America and all over the world with the high pressure levels. What you need, of course, you need to have right nitrogen bottles. You have to have the right pressure reducers, and of course the right hoses, fittings and adapters. Why I'm mentioning that? Because normally refrigeration guys don't have the pressure reducer. Is easy, you can get from the shop, but not the right hoses for the right pressures. And this is of course dangerous. That it's not easy if you use the wrong hoses, which have only a license for go up to 30 bar, and you go up to 120 bars. So you have to have the right hoses, fittings and adapters, which is also nowadays a commodity and quite cheap to buy. But as we said, as manufacturer, we have to tell customers which are new in the market what you have to do and what you have to buy, what you have to take care for. Otherwise, just to supply a rack is easy, but it's really something a little bit about training. But nowadays, as I said, it's not anymore a big problem. Safety valves are required, like in a normal system, if you are according to the pressure directive. And of course, here you see different design pressures, but it's not only us, also other ones supply, but we always recommend to install the safety valves outside of a building. If you have the rack inside of a building, install the safety valves outside. If you have a blow-off that you don't have the CO2 in your room, the CO2 is basically not the problem because we have CO2 detectors and so on, but there's always a lot of oil mixture inside of the gas, and then you're diluting a little bit your machinery room. So that's why we say, please provide it outside. Yeah? That's why we say never mount safety valves inside buildings. So we always try to mount it outside. If you have an outside unit anyway, then it's not a problem because it will be just like that. And one thing which is also a little bit here, you see a picture of a rack in installation. During startup, what people have to understand, you cannot set only medium temperature and low temperature if you have a rack which is supplying both, because in CO2 is a booster rack, it is all in one. So if you start up one, the other one need to be started up too, because there is an interference. It's an open system. That if you want to plan it, because sometimes we see, hey, I just want to start the low T as a LT temperature, which is not easy because you have empty capacity too. So you have to balance it before, and you have to talk to your supplier before what you want to do, because the system has to go a little bit together. And also the maintenance is the same. You cannot maintain a medium pressure side without taking care of the low pressure side, because if you maintain, switch off the compressors, the LT side is also not working. This is something you have to take into consideration. Here you see a picture of different circuits. If you have, for example, with R449A, you have a separate system for MT and for LT. With CO2, you have both in one, which is, of course, giving you efficiency, but also you have to know that and you have to take care, which is not a big thing, but people have to understand that. So we are really onto the basics. And you have two more valves because you don't have a cascade heat exchanger in that case. You have a high pressure and a medium pressure valve, which keeps up the right pressure levels in that side. They are located at the rack. So, but the people have to understand, if one time they understand the circuit, the PNID, together with the logarithmic diagram of CO2, how it works for a normal refrigeration engineer, it's quite easy to understand. And as far as I know, the Asian engineers are really on a high level. I don't think that is a big problem. But one thing is important for installations, the circuit has to be cleaned. So if you brace your material inside, your piping, cleanness is very important, because CO2 is a very good refrigerant, but the molecules are also very small. So you can get a lot of dirt from the pipes out into the system, and then the valves can be blocked. So you need to be careful that you have a clean system, like in other systems too. But even with CO2, you should take a little bit more care of that. And of course, that you mount the right temperature probes on the right side, on the right space, which is also important. We saw some breakages of compressors. Basically, it was in Colombia because the customer did not install in a correct way the temperature probe of the evaporator, and it was an industrial evaporator which brings a lot of liquid back to the unit. And after correction of that, it was working proper. But this would happen also with a Freon unit. It would be the same style. It would have the same problems. So it's nothing special about CO2, but you need to take care of that. And piping dimensions, this is something very important. It's also something where, depending on the application, the CO2 is also financial-wise interesting, because if we have a lot of piping inside of a building, with Freon, the pipes is getting very big. I have a comparison on the next slide about the different pipe diameters and the same capacity. because CO2 has a significant high volumetric cooling capacity. There is a simple configuration with a Danfoss cool selector. I name the name here because it's open software. You can calculate your pipe dimensions very easily without any problem. So, because we see also in the beginning, the people oversizing the pipes because they were not sure of that. So they did stainless steel pipes in the beginning with a very big diameter. If the diameter is too big, it's also not good because then you don't have the proper oil transfer anymore. So a system like in a Freon system should be sized correctly. And then you are saving also money on that. So you see different pipe dimensions, liquid line, suction line for R134A, R404A, R717, and R744 CO2. And you see that the suction line especially is getting significantly smaller. It's nearly half of the size like of a Freon system. And that is also where you can save the money if you do it proper, because if you have 200 meters of pipe length and your diameter is just half of it, of course, there is some price impact on that. But also the piping is not is something which you have to take care if you make your first planning to have the right piping at the side. So this might also happen. This is a picture from an installation in Colombia. Basically, the system was planned with an ammonia, and later on it was CO2. So they made a big hole because it was planned for stainless steel ammonia. I think it was DN250. And basically, this was the CO2 line coming in. Even for ammonia, it was a little bit big, to be honest. But this picture shows exactly you don't need to have such a pipe opening. It's like that what you need finally. Because if you compare it in the beginning, then later on you don't have problems at site. So we are in Europe, we are using, it's called K65, which is a copper which has some iron inside to be more rigid. There is also different suppliers available. You can have also just copper. I think there is some suppliers from China which do that, which have a bigger thickness. There is also some supplies from other manufacturers outside Europe where you can buy that out of. We're working with Wieland in our factories. That's why we brought Wieland in, but there's also other companies available. It's easy to handle on site because it is copper. So it's easy to brace instead of welding when you go to stainless steel. So we saw the first installations, the customers were not able to source it at site, so they tried to do it with stainless steel. Stainless steel, yes, you can do. You have to have the right connections on a machine. It's not a problem about the pressure, but it's a matter of a price. So we made a comparison about an example of a warehouse in Ecuador, K65, so special copper versus steel with 10 bows and the working time. So we see that the working time, it was calculated by the contractor at site. It was still a conservative calculation. And he sees that he needs double of the time, K65 to steel. And the problem also at site is that you don't get qualified welders easily, but people who can solder brace, you get easy normally at site, because this is the normal refrigeration engineers you need. But for steel, you need basically more the ammonia guys or some specialized companies with certificates, which is more expensive for the pipe work. So that's why we recommend to use a copper. And for some applications, like for Israel, we supplied also the copper with it. So we gave them everything to be ready, including all the spare parts, which is another point I'm coming to. Spare parts, this is also important, what you have to have on stock. So you should always have a second controller on site. You should have also an optical sensor, oil regulator, and some pressure transmitter, and of course some maintenance material. If you start up with something like that in a new country, you need to do that, because you cannot go to a wholesaler and ask for that, because then delivery time is maybe 4 weeks because they don't have it on stock. So the emergency part, you should always have that. The investment is not so big, but later on it pays off, what we see, because later on you can use it anyway, and it's getting a commodity. Then it's something which is working in a continuous way, and people have to do that. So you have to consider that you have to have some spare parts on the side. And of course, the perfect amount of CO2 and oil, because CO2 has to have the right quality, which is easy. It's a cheap refrigerant. but also you have to have it inside. And of course, the right oil charge. So if you talk about with us before or with other manufacturers, they can tell you, hey, for our plant, you read roughly around this side of oil, this side of CO2, and then you can get your filling. It's not so difficult. So the Israel guys, for example, got their CO2 from Turkey because in Israel there was also no CO2 at the market for such application, but it was solved easily and the price was also cheap. No? Because over and under filling, like in a Freon system, can cause contamination and is not good for the system. And you need plenty of CO2 on site. This was the example we told before in Colombia. So we had around 700 kilogram, but the bottles were only small bottles. So we had to have 40 bottles at site and the bottles have to go back to be refilled and come back. So our staff have to wait 3 times to get the unit really filled because there was not enough CO2 on the market because the planning was not proper in the beginning. If the planning would be proper before, this would not be a problem because then you order 1 big bottle and it's done. So it's something about experience. For the next time, this installer didn't ask anymore for the 40 bottles. He asked for 2 big bottles and that's it. Handling components before installation, of course, like usually, like in every system, the seal components, you have to seal them during transportation. Humidity and water are contamination for every refrigeration system. So it has to be cleaned before and you have to make a proper vacuum before you start it up, which is very clear because this is a commodity and you have to use for all systems. And after startup, also very important, you have to do a maintenance like you do on a normal system. You have filters inside, you have oil filter, which you have to take care for. And this is something which is still underestimated. If you see how often you go with your car to change the oil and the oil filter, you go quite often. And how often do the refrigeration guys go outside? If you really look on the running hours compared to a car, change the oil filter or oil. So of course, filters have to be changed and have to be cleaned because then you have a long-term running unit. This is not only due for CO2, but in CO2, it's also important to do that. So, and of course, in the oil filter, the coalescence cartridge, which is in the oil separator, is very important to be changed because this is basically the most filter in the system where you get all the dirt. So it's very easy. You can stop it. It's done within 15 minutes, change it, bring it back, and then you have a running unit for the next year. But filters need to be changed. Steps to start up, just to summarize again, dimensioning of the components. That means also including the evaporators, the gas coolers, piping, valves. System and rack components have to be clean, that's clear. Pressure tests have to be done in the right way. You have to make a proper evacuation of the system, then have a proper correct filling during startup, and you have to do a maintenance during operation, which works quite well. And we see it even in the example of Israel, we don't have to go outside and it works. So these guys just ordered a second rack. So they will be started up, I think, in January. The next cold storage will run then also in Israel. That's all from my side. I hope it was a short input. It can be much, much more, but we have to bring it down to a nutshell. So it's also easy to do the installation if you have a contractor which takes care. Thank you. That's all from my side.
Thank you, Andreas, for a fantastic and very spot-on presentation. I believe this is something that the Filipino industry appreciates because, as we all know, there is yet to be the first installation happening in Philippines. However, there are several interested parties, so this might be very relevant to the local industry. Now, can you please comment on why there is such a disparity between Latin America and, let's say, Southeast Asia? Do you believe there is some specific reason for that? Is it the policy?
It's not the policy, basically. It is about some local stakeholders, contractors, basically, and also end users, which want to do the marketing on the green side. So you see in South America, you see a big difference between the poor and the rich people, like in Asia. But the rich people go to the high-level supermarkets and they want to spend the money, but they also want to take care for the environment. So for them, it's also kind of marketing that say, hey, our supermarket has a green. So our refrigeration is green, And this is a marketing thing also for the customers, and the customers appreciate that. I think this is more or less one of the major topics coming into site. And after the contractors have installed the first unit and they see everything is running smoothly, they see there is not a big difference concerning Freon, and the price is also not a big difference anymore. So it's getting running and it's getting a commodity. And then we see, hey, cold storages are done. We see all these things are happening. So it's quite nice. But for me, it's a little bit a pity that Asia is not picking up in the same way, to be honest. Because I know a lot of refrigeration engineers. Sorry?
Please go ahead. Please go ahead.
Yeah, I know a lot of Asian refrigeration engineers, which are really top of refrigeration. So they have much more knowledge than when I was the first time in Asia. I was surprised about the knowledge level. I thought I have a high knowledge level, but to be honest, I don't have. These guys have really a high knowledge level. So
would it be fair to say that then in Latin America, the uptake of CO2 transcritical is driven by the end users, the retailers, the cold storage? Maybe that's what we see still a bit absent in Southeast Asia.
Yes, it is driven by them. It's driven by them.
Okay. Then come to your business in Southeast Asia. Are you in business? Are you ready to be working with the local industry in different countries of Southeast Asia? What is your current structure?
Yeah, basically, we have a factory in Thailand near Bangkok, and we have a sales office in Singapore, and we are waiting to evaluate the right customer, to start something up. So you cannot shoot with a rifle and do with everybody the same. You have to say, if somebody's interested, yes, we have to develop, because then you have to train, and somebody has to take the effort to be trained. It takes maybe 1 week to be on a level that he can offer something, and then you start from there. And the first installation, of course, is a bigger effort for us and also for the customer. But after that, it's something which is running, which we see. So it was also crazy for us. The Israel guys, for example, they started up without calling us. They never started up a CO2 unit. They started up without calling us. Afterwards, they called us and said, hey, it's running. Okay. You didn't call us. Okay. But they managed by themselves. If you have guys which are interested, I think they can do it. Yeah.
We will be sharing your presentation, the slides, and this recording also through our Cold Chain Innovation Hub project, because we believe there's a large demand for this kind of information. So we believe that this will definitely be something to follow up on by the local industry. Now we have a technical question here. I will also push it to the audience, and I will read it out from Cesar Lim. As of now, CO2 is available in the Philippines. This is produced as a byproduct of the distillation process. What is the required purity for the refrigerant-grade CO2? Would you be able to answer this?
That's a good question. Now I have to look up into my papers, which I don't have here on my desk, to be honest. But I can give you this information later. It's not a problem. You can see my links there, and you can just write me an email. There is a certain level of, which is higher than the standard you're using in the beverages industry. So it's a little bit higher grade of cleanness, but it's not so different. So this CO2 grade is used mostly in industrial applications also. So it's nothing special. Normally it's available in the market on large quantities.
Excellent. And we can follow up on the question, and we have also shared your contact details. Now, last year in Bangkok, you actually brought along a CO2 transcritical unit that you have run at the site of the Atmosphere Asia in Bangkok, and you have offered the training for the local industry. Can you tell us a little bit more about the follow-up on the training in Thailand? Do you see potential leads to projects on the ground?
To be honest, there was not really a follow-up from the local guys, which actually had the training. So I think at that time, Thailand, as you know, is at the moment a little bit in a situation where economically is not so clear. So people were not focusing on that one. Unfortunately, they were interested in that, but the problem is always somebody has to take the first step. And this is something which we at the moment don't see. But I can tell, even in Europe, the end users and the big end users are looking for the biological stuff. And that means also the whole cold chain has to be on the natural side. So it doesn't make sense to have a banana or whatever, which is produced biologically, and then it's transported with a lot of F-gas emission. This will not happen in the future anymore. So this has to be also taken into consideration. There will be something coming up in the near future. I'm very sure.
Okay, thank you. And final question, I cannot resist but ask you about the studio that you are in. This is a virtual studio by TECO, and you have developed basically a standalone facility or training facility, R&D, at the occasion of the last virtual trade show. Can you tell us a little bit more about how you communicate with the customers these days using these new platforms?
Yeah, we have to use that. You know, we have now our center here. We have the units around. So if we have some new units, we make some opening with the customer, and we nowadays have meetings like that. We also have now a mobile camera where we can show our factory and go through, because at the moment there is no meeting possible in Europe. But the customers are asking for something like that. So we have to have that. And this is a perfect platform here, you know, to have all this booth around. And I think in the near future, it will be staying like that. But it's also very convenient, to be honest, to communicate with people around the world and show them our solutions on an easy way. And it's not the same like meet personally, to be clear. But at that time, I think it's the way to go. You have to combine the virtual, but with the real thing. Otherwise, if it's only virtual, I think it's not our mindset. It's not easy for people to understand. So you have to have something to touch, and you have something to explain on a real something standing there. This is our philosophy, at least.
I might be leading nowhere with this question, but would it be possible for you to turn the camera around and show us what you actually have in your studio, or it might be a different facility, just in case it's possible?
That will not be possible, because the laptop and the camera is already very tight. If I turn it around, I will go up. That is the problem at the moment. So I cannot, because the laptop is there and I'm alone here, so nobody can move it. I'm sorry, but yeah.
Don't be,
it's a pity.
I can then invite our listeners to the next virtual trade show that you will be part of, which is in February 23rd. So we welcome everyone to join. Andreas, thank you very much.
Thank you.
This is great contribution to this conference and to the development of the Filipino cold chain industry. So thank you again for joining us, and have a good day.
Thank you. You too. Bye. Thank you.